you guys write down the function? So you can refer to it later.
You can plug 1 into the bottom.
It's 1 plus 1.
Yeah, so it would be.
Oh wait, it is. Oh, it is 3 over 2. I'm stupid.
Brian, you're not stupid.
I agree. No, I was thinking to myself and I realized that I got it.
You guys agree?
English.
Yeah.
Convict.
Oh.
I'm frozen.
You guys agree?
Yes.
Same. Yes. You guys agree?
Yes. Yes. Yes.
Stand up if you got it all right. Oh my goodness. Hey, high tens. Anybody standing? Go find each other. High tens.
Hey, Jacob.
Everybody else, ask a quick question if you have it.
Are we allowed to laugh with each other?
Yeah.
You weren't supposed to.
Okay.
All right. That was good talk. Not necessarily super bad to collaborate if everyone in your group has finished or everyone within earshot has finished, right? But if you're collaborating in a way that people are doing it and they're like, oh, that's how you do it, you just kind of shortcutted, broke the process for them. Does that make sense? We're going to have lots of sample multiple choice, some sample FRQs, especially in BC because we're going faster and there are some nice like practice quizzes, practice tests that we'll work on. So yeah, let's be careful of that. But I wasn't totally against collaborating as long as everybody had tried and your collaboration is like your grading. Does that make sense?
Yes.
As long as everybody in your group has finished or everybody within earshot. AKA if you are giving answers and someone is listening, then please don't. Okay, a quick word to the wise. I believe in your RunWeb. Both your summer review quiz and your polar parametric quizzes have been inputted, true? Everybody did perfect on both, right?
No.
No. So here's what we're going to do. Normally I would pass them out and then have you guys do whatever and then bring them back and whatever, but I would rather have your 0 period stamp sheet this week be you coming in, checking on the quiz, and then doing corrections in here. Or at least checking with me, getting it from me, and that way I can give you like a little bit of personal feedback right there and then. Because some of you were like, oh, it was a lot lower than I wished. And so if I just pass it out to the entire class and then everybody sees it and then they take it home. Well, long story short, I'm doing this with AB, so I'm doing it with BC too, just to kind of be fair. Which means tomorrow morning 0 period could be very productive for you and even a tutoring opportunity for you if you want to help AB with their summer review quiz corrections. But you could also possibly be working on yours and or your polar parametric. So, all that to say, I'm not going to take class time to hand it out, unless we have a lot of class time at the end left over, then maybe. But we do need to get into section 2.2 today, especially with the Spirit Day on Friday, and so we kind of lose a day, and with the senior retreat having already happened. But before we do that, we need to grade section 2.1. But my question is, were there any piecewise functions in your homework? Ah! So, possibly, from the warm-up that we just did, you can have your color pen, you can have it in your homework spiral, we're going there quickly. Because there were piecewise functions in your homework, we are going to do a quick little reminder note for ourselves with the piecewise. Now, a lot of you guys, probably like 1/3 to 1/2, got all 4 right. Perfect. And some of you got 3 out of the 4, 2 out of 4, 1 out of 4, 9 out of 4. So just a quick reminder for our notes about piecewise functions before we go back into the homework where some of you might have gotten stuck on piecewise functions. There are different types of piecewise functions you can see, right? pieces with equals and not equals, and pieces with greater than, less than, maybe sandwich inequalities. Like, you could have 3 or 4 pieces. It could get more complicated. But we still have to kind of have the exact same ideas in place when we're facing piecewise functions. Meaning, if I'm trying to find, for example, the limit as x approaches 7 of this guy, what do I need to think of? Technically, it's the same as I would with this guy trying to approach 1. For any limit, I need to think of the one-sided approaches. And I think, Kevin, was that you? I need to come from the left and the right. But it's going to look differently based on how the piecewise function is defined. So if I need to think about, or if I need to consider both the left and the right to answer both of these questions, well, why would this one have me considering 2 different limits to consider the left and the right, whereas this one would have me considering only one? Why would the second example have me considering 2 different limits to come from the left and the right, whereas the top one would only have me considering 1? The second piece is an equal to, which is an at, which we don't think about for limits. So where's the approach from below and above for 6.9999 and 7.0001? Both of them are contained in the other function. That's the point, and that's everything else. All I care about is the everything else. All I care about is the approach. So if you guys want to think about it, I'm trying to use these words a lot more specifically this year and writing them down, because I know that I say a lot, but not all of you are audible. So in that piecewise, the approach, either approach, both approaches are the below piece the not equal to. The at is this upper one, and every limit does not consider an at, it considers the approach alone. Continuity needs both, but limits only need the approach. So I'm only plugging into the bottom one, that's all I care about. So limit as x approaches 7 of the other piece would equal a constant, not just any constant, the constant. My final answer would be the square root of 7 cubed, which you know what that's going to do, all over 28. Not 73, 7 cubed. So that's the limit, and the limit definitely exists. Is the function continuous? Well, then we would take out that little x and we would say, oh, look at the at. 7 minus 2 is 5. No. This one's going there. It's at 5. Those won't match. But the limit does exist. And it's approaching the square root of 7 cubed. All over 28. Which I guess would be better written as 7 root 7, but whatever. Ooh, because then you could reduce. Go team. That would be a prettier answer if we were to see. But what do I need to do down below? 2 minus 1 would be the below approach. And then 1/2 plus 1. Isn't this what we just did? Did the limit exist? No. Because the one-sided limits did not exist. So when I say plug x equals c into functions on both sides, remember that could just be one function, depending on how the piecewise is defined. The one-sided limits agree, the limit exists. If the one-sided limits do not agree, the limit does not exist. Are we good? Ish? We just hadn't really talked about piecewise functions specifically, and we know that the AP loves to bring in piecewise functions specifically for continuity, but a part of that is knowing how to find limits. Let's go grade our homework. Number 2, 64 feet per second. Number 4, you guys are going to see them do the definition of the derivative a lot. Why? In your book, they haven't learned derivatives yet. In your book, they haven't learned derivatives yet, so therefore they were doing the difference quotient. Number 4 is 128.16 feet per second. And they were approaching the 0.01 and then the 0. Number 10 ends up equaling 5. Number 28, final answer is negative 1/4. And on number 28, you could have used L'Hopital's, but I don't know, guys. I think I would have rather have used definition of the derivative. If you made the connection of this being an f of a plus x minus f of a all over x minus, wait a minute, f of a plus h minus f of a all over h. You could have done the definition of the derivative, but if you were doing it algebraically, oh man, I would have simplified the complex fraction. Boom, quick simplification, there it is. Number 42, did you guys get that the one-sided limits did not agree? So the limit from below is negative 1. The limit from above is positive 1. So the limit did not exist. Oh, are you just coming from below? Oh, you're just coming from below. Lo siento, I apologize. Negative 1. Lo siento, negative 1. Number 44 is true, false, false. True, true, true. True, 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 true. AKA everybody's true but B and C. Sorry that's weird and awkward though. Those are bigger and these are smaller. Oops, and now they disappeared. Well, maybe that's why they're bigger and smaller. It doesn't like me if I do anything else. Nope, okay. Just kidding. We'll just leave it like that. Number 44, everybody's true except for B and C, which are false, false. Number 60, you were playing with your graphing calculator, yeah? You have a hole and you have a point. The limit does exist and the approach is 0, but the function is discontinuous. Although I don't think they were asking that question because we have not covered continuity yet. That is section 2.3. That's section 2.3. All right, I have like a personal agenda on number 42, so can we take a second and think about number 42? And then I'll go over your guys' questions. For number 42, thinking in the spirit of the epsilon delta proofs, don't worry, we're not doing it. Thinking in the spirit, though, of having a justification as to why your answer is what it is, what would be the proper algebraic way of showing why the limit is negative 1? Not just the shortcut way, not just the, I think it's right way, but what would be a proper algebraic way of showing why the limit is negative 1? Okay, maybe V has too much like weight. A proper algebraic way. Sure.
You could split up the absolute into piecewise.
So what is the absolute value of x as a piecewise function? When x is greater than 0, just x stays the same. But when x is less than 0, opposite. So therefore, if I'm coming from below, which piece is this technically? Right? So I'm specifically dealing, as I come towards x from below, I'm specifically dealing with this portion. So now what happens with x and negative x? Or you could even be snazzier and do something like let f of x equal x over absolute value of x, which equals, you could have made the entire function into a piecewise, which might be even a little bit more proper. So that'd be x over absolute value of x for x greater than 0 and x over negative x for x less than 0. So you could say the limit as x approaches 0 negative of f of x is equal to the limit as x approaches 0 of x over negative x. Do it that way too. But either way. Yep, that's technically why. You didn't even necessarily have to be plugging in like -0.1, -0.01, -0.001. You could have just thought about who absolute value is and his behavior, whether x is above 0 or below 0, and used that as your value. An algebraic way of doing it. Because some of you try to do like the testing way, and you're like, I don't know without my calculator in the table. And that's not good. Okay, sorry. Other questions on homework though? I just wanted to take a quick time out for that one. Anything else we want to see? Odds or evens? Yeah.
On number 4, you said h equals 0.01. How did they get that?
On number 4, because this was talking about an instantaneous rate, the speed of an object at 4 seconds, you guys know, like, hey, derivative. That's one way you could have done it. But for them, before derivatives were taught, they were thinking in terms of limits. So therefore, what they did is they approached. So they started with 0.01, and they thought, like, hey, that's a pretty good estimate. They could have done 0.001, 0.0001. They could have approached. So they said, okay, well, how do I get close to 4? Well, only have the change in time be 0.01. But that wasn't like the magical answer. The right answer would have been 128 feet per second by using a derivative or by using the definition, which we did as h goes to 0. So they just chose something to estimate with. Does that make sense? Kind of like a pre-cal way. They chose a pre-cal way to estimate and then confirmed and said, oh, that should be the actual answer. Anything else you guys want to see? Are we okay? All right. Did you guys notice there was a really cool theorem right above homework that we didn't really refer to much at all?
That's the thing on the
Well, but was it really that bad? Okay. Well, that's a bummer. But wasn't it just looking that sine or cosine was between -1 and 1? It's been so long we don't remember, and it was multiple choice, or was it FRQ? The squeeze theorem was FRQ? Go team. Didn't we have a squeeze theorem on